Hi, I am İlayda Özcan. I will present resistance calculation in circuit experiment as a part of Physics 102 curriculum. This is the outline of my presentation. The aim of this experiment is to calculate resistance in two different circuit configurations, series and parallel configurations. To do this, I will measure current and apply Ohm's law to calculate the resistance in the circuit and compare experimental results with theoretical values. In theory, the potential difference derives the current, which is the flow of charges, and resistors resist this flow of charges. And Ohm's law applies that the potential difference is the multiplication of current with resistance. In the series connection, the same current will go through all of the resistors, so we can just adapt the resistors to calculate the total resistance in the circuit. In the parallel connection, we will have different branches, and in each of these branches, we will have different values of current here, and when we apply the Ohm's law to this formula, we will get this equation. And as a feature of parallel connection, the potential difference across each of the branches is the same, so we can just divide this by potential difference. Then we will get this equation as a total resistance in parallel connection. And when we compare these two equations, we are simply waiting that the series connection has a higher resistance, so a lower current amount is expected. So this is the materials of the experiment: multimeter to measure current, 3 identical 10 ohm resistors, power supply, and crocodile clips to connect circuit elements. This is the series connection. Resistors are connected in series. Power supply drives current, and also we have multimeter to measure current. And this is also in real life setup. Power supply, again, 3 different resistors and multimeter. And this is the parallel connection. We have the different branches, and we have identical resistors in each branch. And in the real life, again, we have the identical resistors in each branch and power supply and multimeter. So this is the experiment video. I started from 10 volt to 20 volt and increased the voltage in 2 volt steps. And I have noted down the current values in each of these voltage differences. Then I also use these data points to fill up a table showing the results. So this procedure is also implemented in both configurations, series connection and parallel connection. So this is a table, and as you were expecting, the current in the series connection is measured lower than the current in the parallel connection. I use also these data points to show in a graph. So we have a y-axis of voltage, x-axis of voltage, x-axis of current, and this is the same graph for the parallel connection. And this is, we have a lower current in the series and higher current in the parallel connection. And also I show the best fit line, and this is the best fit line equation. When we apply Ohm's law, we can simply deduce that the slope of this best fit line is voltage divided by current. So the total resistance in in these configurations will be equal to this slope that we can see here. So this was the best fit line equation. As I explained, the M value here shows the total resistance. So that's why we have a 32.37 ohm experimental R in the series connection and 3.96 ohm in parallel connection. And these are the formulas that I have explained earlier. These are the theoretical R. This is the just adding up the resistance values, 30 ohm, and also same equation, 3.3 ohm in parallel connection. So this is the error calculation. Percentage error is equal to absolute value of theoretical minus experimental value divided by theoretical and multiplied by 100. In the series connection, I have placed these values into this percentage error, and I got 7.9 error in the series connection and 20% error in the parallel connection. So when we look at the errors, we see that the 20% in the parallel connection is higher than 7%. The main cause of this is the heating of resistors. Since we have conducted after this parallel setup after the series, the resistors were warmer, and also in the parallel setup we have a higher amount of voltage, higher amount of current. That's why our resistors were warmer than the series setup. And the publication that is published in the Nature article implies that the collisions between free atoms in resistance and also the electrons in the current collides more in the high temperature. That's why we have this error. To solve this error, we can just simply wait for resistance to cool off before taking under measurement. Other possible errors are power supply fluctuations, resistor manufacturer tolerances, and multimeter resolution. To solve these errors, we can just get a better power supply, get a better resistor which has a lower tolerance of resistance ranges, and also a better multimeter resolution to get a more precise result. So in conclusion, Ohm's law was validated experimentally because our experimental values was closely matching the theory, and we also saw these thermal effects, the heating of resistors, contribute to deviations in resistance. And this thermal effects was higher in the second parallel setup. Thank you for listening.